Section 3 in the C Math 2026 past paper. Question 37. The table below shows the points awarded for each card picked in a card game. So we have the cards, we have ace, we have king, we have queen, we have jack. These are the points: 30, 20, 10, and 5. Total cards that must be picked, 12, and the total points, 155. Now, Anil scored a total of 155 points in 12 picks. He picked the same number of aces and kings, okay? Complete the table to show the number of picks and the total points for each card. Since they picked the same number, I'm going to start off with 1, okay? So if he picked 1 ace and he picked 1 king, the points here are going to be 30 and 20, that's 50. If I take 50 from 155, I will remain with 105. And it means with this remaining points, I need to get how many cards? I have 2 out of 12. So I need to get 10 more cards. That will give me the sum of 105. Now, if that doesn't work, it means I'm going to have to pick more than 1 for ace and king. All right. So again, we are working it out. Let's see how it goes. So I want to get 110. So it's going to be easy. It would have been easy. I need 10. Now, if I multiply 10 by 10, I will get a 100, but I need 105. Okay, so I cannot take 10 and say, well, okay, I will take 1 more to make up 5, because then I would have 13 cards. Watch the numbers. I have 10, 11, 12, 13. Okay, so that's not going to work. I need 12 cards. All right, so this first option is not going to work. Let's try again. Let's try again. I'm going to try 2 this time. So I'm going to use 2 ace and 2 kings. That's going to be 60, because 1 is 30. 30 by 2 is 60, and 20 by 2 is 40. So that's already 100 points. So if I take 100 from 155, I need 55 more points. Now I also have to check and see how many cards I can pick. I have to choose 12. I already have 4. So if I take 4 from 12, I need 8 more cards. So let's see if I can use 8 cards to give me 55. Right? What can give me 8? I can try 7 and 1 first. So if I do 7 by 10, that's going to be 70, and 5, that's going to be 75, more than I need. So that option is not going to work. What else could give me my 8 cards? How about I use 6 and 2? 6 tens will give me 60, and 10, that's 70. I'm still passing my 55 that I need. How about I try 5 and 3? 5 tens are 50, and 5 threes are 15. So I'm still over 65. That can't be. Let's try again. 3 queens and 5 jacks. 3 tens are 30, and 5 threes are 15. We are getting, and 5 fives are 25. 30, 40, 50, we are getting 55. So you see, this is the option that's going to work. So we will choose 2 ace, 2 kings. Remember, they had to be the same number. Queen, 3, jack, 5. We have a total of 12 cards and a sum of 155. And that's it for 4 marks. Question 38. The maximum time Gareth can remain in a video game is 5 minutes. He earns 1 point for every 15 seconds he remains in the game. He also earns a prize for every 6 points earned. What is the least amount of time Gareth must stay in the game to win the most prizes? Okay, so let's take it one step at a time. The maximum time he can spend in the game is 5 minutes, and he earns 1 point for every 15 seconds. So the first thing we're going to do is to determine how many seconds there are in 5 minutes. Okay, how many seconds there are in 1 minute? 60. So to determine how many seconds are there in 5 minutes, We're going to multiply 5 by 60. So 5 minutes multiplied by 60 is going to give us 300 seconds. And this is important. Why? The question told us he earns 1 point every 15 seconds. So how many 15 seconds would we have in 300 seconds? And how many points would he earn? For each one, he would earn 1 point. So if I divide 300 seconds by 15, I am going to get 15 into 30 is 2, 15 into 0 is 0. I am getting 20. So it means, and remember, for every group, he's just getting 1 point. So he is getting 20 points. The question goes on to say he also earns a prize for every 6 points earned. So he has a total of 20 points, and for every 6 points, he is getting a prize. How many prizes would he get for 20 points? You'd have to divide 20 by 6. How much times 6 can go into 20? 3 times. So what does that mean? He's going to get 3 prizes. Let's walk it through again. He can stay in a game for 5 minutes. That's 300 seconds. He's earning 1 point for every 15 seconds. So we divide 300 by 15 and we got 20, right? So 20, 15 seconds they are in this game and he's earning 1 point for every group of 15. So he's earning 20 points. In addition to that 20 points, he's earning prizes for every 6 points. So out of the 20 points, every 6 points, he's getting a prize. How many groups of 6 do we have in 23 groups of 6? 6 threes are 18. So that means he's going to get 3 prizes in addition to that. What is the least amount of time he must stay in the game to win the most prizes? Well, for the time that he has to stay in the game, we're going to multiply 18 points. For 18 points, he's going to get 3 prizes. So for 18 points, we will need to multiply that by 15. 18 by 15 will give us 1 8 is 8, 1 1 is 1, 5 8s are 40, 5 1s are 5, and 4 is 9. And we are getting 270 minutes, right? So to earn his 18 points, we multiply 18 by 15 seconds, and we are getting 270 minutes. So this is the maximum amount of time that he needs to stay in the game to earn the most amount of prizes. Remember, he could only stay in 5 minutes at a time. And the question wants the answer in minutes and seconds. So 270 minutes is how many minutes and seconds? We can simply divide 270 by 60. How much times could 60 go into 270? We could count in 60, you know, 60, 120, 180, 240. So we are getting 4, and each one represents a minute, right? We are getting 4 minutes. And all I need to do is to subtract 240 from 270 to see how much seconds remaining. We are getting 4 minutes and 30 seconds. So to get the most amount of prizes, he needs to stay in for 4 minutes and 30 seconds. A cube is cut into halves to create 2 identical prisms as shown below. This is the front of the cube. And this is how it looks when it's cut. This is the front, prism A and prism B. The plane shapes at the base of the cube is shown on the grid. So the cube on the same grid complete the drawing of the plane shape at the base of the prism A. We have the base of the cube, it's a square, and the plane shape for the base of the prism, as you can see, if we take a good look, it's the same thing on top. What are you seeing there? A right angle triangle with a base of 1, 2, 3, 4 as well. Okay, so this is the base of prism A for 2 marks. The question says that prism A and prism B are joined at 2 square faces to form a new prism. Let's look at it. Prism B and prism A, they are being joined to form a new prism. This is the new prism, and the prism formed is a cuboid. Now, students would see all of these words, all of these drawings, and be intimidated by it. But if you read through everything, you would see how straightforward this question really is. The plane shape at the base of the new prism is shown on the grid below. No problem. Let's get to what they're asking us for. State two similarities between the cube and the new prism. So let's look at that. The cube and the new prism. What we said the new prism is? A cuboid. What are the similarities? What do they have in common? What are the similarities between a cube and a cuboid? They have 6 faces. Another similarity, they have 8 vertices, as well as 12 edges. The question asks for 2, but we are listing them all. And just state this for 2 marks. Last question on the paper. The incomplete picture graph below represents the fruits liked by children in a group. So in the group, 55 more children liked bananas than oranges. The number of children who like apples was greater than 40, a factor of 180, and a multiple of 9. The second, and it's also the second largest number. So they said the group 55 more like bananas. How many more do we have than oranges? We have 1, 2, 3, 4, 5.5 more. All right, so this 5.5 more is equal to 55. So one of the easiest things you can do is to check. Some persons will begin to count in tens, begin to count in fives, begin to count in twos to see if this works. If you're not sure, you can simply divide 1, 2, 3, 4, 5, divide 55 by 5.5 or 5.5, and you'll get the answer as well. Okay, so we can check it here. We will see it's 10, 20, 30, 40, 50, and half is 5. So that's telling us, you see, finding out your key first is very important, right? So this smiley face, one smiley face represents 10. And again, if you didn't know that, you could simply divide 55 by the smiley faces you're seeing here. 1, 2, 3, 4, 5.5. What do we do when we are dividing decimals? There can't be any decimal point in our divisor. So if we shift it once to the right, this will now become 55. Once we shift it once in our divisor, we also have to shift it once in our dividend. So we're getting 550 divided by 55. 55 and the 55 is 1. 55 into 0 is 0, and we are getting 10. So whether you eyeball it and you checked it or you worked it out, you'll get the same answer for the key. So one smiley face is equal to 10. Now we have to find out for apples. And they said the number of children who like apples was greater than 40. Is a factor of 180 and a multiple of 9. So immediately I'm thinking factors of 40, factors of 180, and I want to think about the factors that are greater than 40 as well. When you think of factors, what do you think about? The numbers that you multiply to give you 180. So that's going to be 1 times 180. What else you can multiply to give you 180? 180 is even. So 2 by 90. What about 3 by 3 can go into 18 6 times. 3 into 0 is 0. 3 by 60 will give you 180. What about 4? 4 can go into 180. Five. Four can go into, if you don't know how much times 4 can go into 180, you can simply divide. 4 into 4 is 1. 4 into 18 is 2. 4 into 18 is 4. With a remainder of 2. 420 is 5. So we're getting 45. $180 ends with 5. So I know that it is the 180 ends with 5. So I know it is divisible by 5. How much times could 5 go into 180? 5 into 18 is 3, with a remainder of 3. 5 into 30 is 6. So 36. But again, we want to use the factors that are greater than 45 because it tells us the answer. We want to choose the factors that are greater than 40. So we would leave this one out and look at the factors that are greater than 140. Look at the factors that are greater than 40. They tell us because apples is greater than 140. They also said it's a factor of 180. We identified the factors of 180 that are greater than 40. And they also said it's a multiple of 9. So we have to now choose the factors that are multiples of 9. Okay? So 180 is a multiple of 9. 9 could go into 180. 90 is a multiple of 9. 60 is not a multiple of 9. 45 is a multiple of 9. So the options we're working with is 180. We're paying attention to 90. We're paying attention to 45. They said it's the second largest number as well. So the number of persons who like, the number of children who like apples was greater than 40. It said it is the second largest number. It's not the first largest. It's the second largest number. It's a factor of 180 and a multiple of 9. So which one is fitting that, checking out that box? It is the second largest number. So bananas, which is 10, 20, 30, 40, 50, 65 is the first. 10, 20, 30, 40, 10 is going to be the second largest. So we are going to go with 45. It's not the first largest number. It's not the largest number. They said it's the second largest. So we are going to choose 45. And how would we draw that? 10, 20, 30, 40 and half. 4, 45. And of course, your smiley faces can look much better than mine's. Yeah. And that's all for question 40. And this is the end of the C 2026 math paper.